We are going to be starting on chapter 8, and the first one is about samples and population. All right, so there's some important info we're going to want to know for today's lesson. First up is a population. This is an entire group of people or objects. So let's talk about the population of Jacksonville. Does anyone have a guess of how many people you think might live in Jacksonville?
Isn't it like 3 million?
Okay, 3 million. Who else has another guess? 2.7 million? 2.9 million?
Really?
1 million? On the dot. Grab a candy. There's about 1 million people in Jacksonville, okay? That is the population of people who live in Jacksonville. Now, let's talk about the next part, a sample. A sample is just a part of the population, okay? So we could have, there's different sections in Jacksonville, the north side, or we live on the west side, some of us, our school is here on the west side, there's the south side. Okay, so a sample is just taking a small group of people of the population. Now there's two different parts of a sample. One is an unbiased sample and one is a biased sample. Okay, so let's just say, I say to you guys, I have the cutest kids on the planet. Do you think I am biased toward my children? Yes. Why? Because they're my kids. I love my kids, okay? So let's talk about biased and unbiased sample. You do not want a biased sample. Why? Because it's not really a good representation of what we're trying to figure out, okay? Yeah, I think my kids are the cutest, but my friends think their kids are the cutest, okay? So we're talking about biased versus unbiased samples. An unbiased sample is a representative of a population, and it has to be two things. Repeat after me, large and random.
Large and random.
If a sample is not a large sample, like it's sampling a lot of people's opinions, or it's not at random, then it's not going to be accurate, okay? So then you've got a biased sample, and that is not representative of a population because one or more parts of the population are favored. Okay, so we're going to get into the unbiased and biased sample, but first I want to talk about the difference between a sample and a population. So if you look in your notes, we're going to identify which one of these things is the population and which one is the sample. So for problem 1A, I've got the box of Lucky Charms and then I have the marshmallows in it. How many of you would say your favorite part of Lucky Charms is the marshmallows? All right, I think that's what a lot of people would say. I remember as a kid, I used to eat all the little brown parts first and then just save all the marshmallows at the end, okay? So of those two, which one of those do you guys think is the population? Remember, a population is the entire group of people or objects.
Lucky Charms.
The box of Lucky Charms is definitely the population. Why? Because that's the large part that we're talking about. So what would just the marshmallows be called, guys? The sample, all right? That's just a small part of the population. So now, from what we did on that one, problem B, I've got the residents of Jacksonville, and then I have the residents of Florida. Which one of those do you think is the population?
The residents of Florida.
The residents of Florida. Why? Because that is the entire group, the entire thing it's talking about. Now, what would the sample be? The residents of Jacksonville. Okay, because that's just a part of the population. Do you guys see the difference between sample and population? Okay, so on tonight's homework, you'll have a few questions that ask you things like that. Identify and try to figure out which one is the sample, which one is the population. For this part, it's asking us to determine if the sample is biased or unbiased. So for problem A, you want to estimate the number of 12th grade students in a high school who eat pizza for lunch. You survey all the students on the soccer team. Do you guys think that's biased or unbiased?
Biased.
That is definitely biased. Can anyone explain to me why that would be a biased opinion? What do you think?
Because they're only surveying the soccer team.
You are correct. So write this down. The sample favors the soccer team. Okay, so if I am truly trying to get a good opinion here and really figure out whether this conclusion makes sense or not, I've got to make sure that my sample is large and random. Instead here, all I asked was the soccer team. Well, maybe the soccer team is eating healthy, so they only want salad. They don't want any pizza, okay? So that's not going to help us to understand what the entire 12th grade wants. All right, let's try another example, problem B. You want to estimate the number of students in a high school who ride a bus to school. So that wouldn't be ours because we don't have buses that come to our school, but you survey 100 students at random during lunch. What do you think, biased or unbiased?
Unbiased.
Unbiased. Why would this situation be an unbiased sample?
Oh, unbiased.
Nehemiah?
Because it's asking for like a random amount of people.
Okay, it's asking for a random amount of people. What else?
It's a large population.
It's a large population that you asked. You asked 100 people there, okay? So in order to have an unbiased sample, you've got to make sure the sample is large and random. And this definitely meets those qualifications. It was a large and random sample. All right, one more example. We're trying to find out if it's biased or unbiased. You want to estimate the number of 8th grade students in your school who find it relaxing to listen to music. You survey 15 randomly selected members of the band. Girls, what do you think, biased or unbiased?
Biased.
Biased. Javaria, why do you think that's biased?
It's not large at all.
She says it's because it was small. All right, but look, she also pointed out, but it was randomly selected. Do we want it to be random?
Yeah.
Yes, but in order for something to be biased, what do we need?
It has to be random.
Large and random.
Okay, sorry, for it to be unbiased, it's got to be large and random. So, although this was random, it was not large. So our reason why it was biased, she had it correct at first, the sample is small, and it favors who?
The band.
It favors the band, okay? If you're trying to figure out all the 8th grade students, all of the 8th grade students are not in band. And this, in order for something to be unbiased and to be a good, accurate sample, you've got to make sure it's large and random and it doesn't favor only a certain group of people. For number 3, you want to know how the residents of your town feel about adding a new landfill. Determine whether the conclusions are valid and justify your answer. Now, as you can see up here, I put up here in red. The conclusion is valid if it's what kind of a sample, guys? Unbiased, all right? And the conclusion is not valid if it's what? Biased. Okay, so if you remember, we do not want biased samples. All right, now let's talk about a landfill. Does anybody know what a landfill is? Janet, what's a landfill? It's a place where they throw away lots of trash, okay? So let's imagine at your house, you've got something in your refrigerator, it's rotten or expired. How many of you have ever had that? Does it smell nice? No, so you stick it in your trash can that's in the kitchen. Eventually, does your kitchen start smelling? Yes. Yeah, so what do you normally do with the trash at that point?
Burn it.
Take it to the trash can where? Outside, okay? And then once a week, what happens to those trash cans that are outside?
They get taken by a garbage.
A big garbage truck comes and gets them. Well, guess what? They don't disappear into the universe at that point. They have to go to a landfill, all right? Now, how do you think a landfill might smell? Disgusting, okay? Would you guys want to have a landfill like this picture? A huge area of nothing but trash. Would you want that near your backyard?
That's a big dumpster now.
No. Why would you not want that? Because it smells terrible, okay? So that brings us to our problem here, problem A. You survey 100 residents who live closest to the landfill. Table A here shows the results. You conclude by looking at that 10 people support putting the landfill there and 90 people do not support putting the landfill there. How many total people did they survey, guys? 100, okay? So 10% of them support the new landfill. I want you to talk to your partner about whether or not this is a biased sample or unbiased, and then does that make it a valid conclusion or not valid? All right, guys, raise your hand if you believe that this is a biased sample. Raise your hand if you think it's unbiased. All right, for those of you who said it was biased, does that mean it's a valid conclusion or a not valid conclusion? It is not valid. Is there anyone out there who can explain to me why was this not valid results? William, what do you think?
No, who would? New landfill.
Okay, very good. This is dealing with the people that they went out and they got the sample from, okay? So whenever you're trying to figure out if something's valid or not valid, you have to focus on who has been surveyed. The people that were surveyed are the people who are living near this new landfill. Do you think many people are going to want a new landfill by their house?
No.
No. If you told me you're putting a new landfill somewhere in Georgia, do you think I care? No, it doesn't affect me. But if you tell me you're putting one in my backyard, I would not be happy about that, okay? So this is not a valid conclusion because if you see, the conclusion here is very biased. Why? Because the sample favors those people who live closest to the landfill, not the whole town. All right, next example, problem B.
Wait, can you go back?
You survey 100 residents at random. Table B here shows the results. You conclude that 60% of the residents of your town do not support the landfill. Raise your hand if you believe this is valid.
No.
Raise your hand if you think it's not valid. All right, everyone here has said that they think it's valid. Can someone explain to me why is this a valid conclusion? Taylor.
Because they went to different people around the town and selected them randomly.
Okay, they selected the people randomly. That's one thing we need in order to see if something is going to be unbiased. And it was a large number, okay? So here you can see the conclusion is unbiased, and the reason why it's unbiased is because the sample was large and it was random. All right, next up we've got a modeling real life problem. It says you ask 75 randomly chosen students. Is it good to have things at random?
Yes.
Yes, that's what we want. You ask them at a school how many movies they watch each week. There's a total of 1,200 students in the school. It would not be easy for me as one person to go and ask 1,200 kids, hey, can you tell me this about how many movies you watch per week? So instead what you do when you cannot ask the entire population, you take a sample. Once again, needs to be a large and random sample to help get you something that's good information. Now what we want to do, if I know there's 1,200 students in the school, I've got to estimate the number of students. What does estimate mean?
Yes.
Guess. Take a good, educated guess of how many students in the school will watch only one movie each week. Okay, so how many of you would say you watch at least one movie a week? Not just TV shows, but like an actual movie. Okay, a few of you. How many of you would say you do not watch a whole movie through every single week? Okay, so once again, we're taking just a little bit of a sample from our class. So here's what they came up with. If you look over here, how many kids out of those 75 watched one movie in a week? 21. How many watched 0 movies? 30 of them. And how many watched 2 or more movies?
24.
So that's the information that they came up with there. So what we're going to do, have you guys ever heard of this, favorable over total?
No. I mean, yeah.
Yes, okay, that's what we used when we were trying to figure out probability. And then does anybody remember what it was called when I had 2 fractions that equal each other? A proportion, okay? So what we're doing is we're taking things we learned with probability and proportion, and we've come up with this little thing that's going to help us. We're going to take the favorable, that means what we're looking for, over total surveyed, equals n. N is the thing we're looking for. We're trying to figure out how many students in the school watch one movie a week over the total population. So let's plug some numbers in. Favorable. How many students did we see out of our sample that watch one movie each week? 21 of them watch one. So let's write it over here. Over the total survey, how many total people did we survey?
75.
We surveyed 75 people in the school. Equals n. Remember, n stands for the number of the students in the school who watch one movie a week. We're trying to find that out. So right now, that's our mystery n. We don't know it. Over the population, how many total are in the school?
1,200.
1,200. Does anyone have a clue how I will identify what that n is? We're going to do some cross products here, okay? So we're going to multiply this and this. 21 times 1,200 equals 75 times n. Okay, guys, what's 21 times 1,200?
336.
25,200.
Very good. Equals 75n. How do I get n by itself? All right, when you do that, what do you get?
336.
All right, so this is modeling real life. What are the units that should be attached?
Movies.
Okay,
Per week.
look. Estimate the number of students who watch one movie a week. So the answer is 336 students. Okay, some of you are saying movies. Always go back to the original problem to ask yourself what it is they're looking for. So they did not actually go out and specifically ask all 1,200 and found out that 336 said that they watch one movie a week. Instead, they estimated or they guessed about 336 of them are probably going to watch one movie per week. So for this, it's a review problem. We're solving the inequality, and then we're going to go ahead and graph the solution. Remember, our goal is to get x by itself. It's a two-part problem. The 5 is attached to the x. So remember, we called them what?
Variable.
Like best friends. So you keep them together as long as possible. Let's get rid of the 4. How do I get rid of it?
Subtract by 4.
Minus 4 on both sides, which leaves me with 5x is greater than or equal to 10. How do I get rid of that 5? Divide by 5. So guys, what's your answer?
X equal or
Okay, what is that symbol right there, guys? Greater than or equal to. Okay, so x is greater than or equal to 2. How many numbers should I have on this?
4.
3. What number goes in the middle?
2.
What's smaller than 2?
1.
And bigger?
3.
Open or close circle? Close. Now if you look, this right here says all solutions are greater than or equal to 2. So which way do I go, to the right or the left?
The right.
I'm going to go ahead and go to the right because all numbers that way are greater than it. How many of you got that review problem correct? All right, very good. Although this problem right here is not in your notes, it's going to help you on your homework tonight. So let's talk through this. You ask 50 artists about their favorite art form. Determine whether or not your conclusion is valid and justify your answer. So you can see right here there's a little drawing circle graph that shows us the different favorite art forms. Looking at this, what can you conclude was the favorite art form, guys? Drawing. Which one seems like the least favorite? Ceramics, okay? Now look, they sampled 50 artists. You conclude that 15% of the people chose painting. I want to know if that's valid or not. What do you think? Valid means truthful. Is that truthful or not? Talk to your partner and see if it is. I'm hearing a lot of people tell me that you believe it's not valid. If you think that is not valid, I want you to explain to me, why is it not valid? What do you think?
Okay, so if it's 15% and then if we have 50 artists, the paintings is 6. If you do 6 times 2 equals 12.
What he's saying right here, if I look, I can see 6 people of those 50 enjoyed painting. So 6 out of 50. All right, when I come to that, what percentage is 6 out of 50?
12%.
12%. Is 12% the same thing as 15%? No. So my question here is asked, determine whether or not it is valid. Not valid. Why? Because it was what?
12%.
It was only 12%. Okay, so that will help you with your homework tonight because you're going to have a problem that looks kind of like that. Okay, so right now what I'm going to do is I'm going to go ahead and give you a few minutes that you guys may start working on your homework.